Welcome to Milak Online Tutorial. Now before us is this question in elasticity in physics, and it reads that a stone of mass 20 grams is released from a catapult whose rubber is stretched through 5 centimeters. Now if the force constant of the rubber is 200 Newton per meter, now calculate the speed with which the stone leaves the catapult. Now, for us to understand this question better, I want to give us a pictorial illustration of what the question implies. Now, you have a catapult. Let me just draw it this way. Okay, then this is the handle. Now, with its normal rubber, okay, with a stone like this. All right. Now I choose to fire this stone, then I decide to stretch. Now by stretching, there is an extension of the wire to this point. Okay, so before I fire, and as I fire, it flies. Okay, now, so take note of this extension from here to here. Okay, now take note again, but before then, now that we've gotten a bit of what the question implies, let us write the parameter. We have mass to be 20 grams. We need to change this to kilogram. Now giving us, which means we will divide by 1000. 1, 2, and 3, that will be 0.02 kilogram. And we have rubber is stretched through, so which means here is actually 5 meters. Okay, so that's extension. That is E equals to what? 5 centimeters. And we have to convert this to meter, which means we are dividing by 100. That will give us a 0.05 meter. Is there another thing we need to look at? Okay, the force constant, since it is under electricity, the force constant is given as K. Sorry, elasticity and not electricity. So here we have 200 Newton per meter. Okay, and we are told to find the velocity. Okay, now here is the twist in this question. Now, there is a work done here in which when we apply a force, okay, on this rubber, which causes an extension of 5 centimeters. Now the work done in bringing this stone from this point to this point, okay, is equals to the velocity at which the stone, leaves the catapult. Okay, so we can say here that the work done, okay, on the rubber is equals to the kinetic energy to which the stone leaves the catapult. Okay, so in this case now, what is the work done here, and what is the kinetic energy here? So now the work done here on the rubber is given by this equation: 1/2, the force constant, the extension to the power of 2, then equals to the kinetic energy is given as 1/2 mv squared. Okay, so to this point, since we have the same term here, we can just eliminate this. So we are left with Ke raised to the power of 2 equals mv squared. Okay, and our V is what we are actually looking for. So we can actually make V the sort of formula by dividing first, dividing both sides by m. So we end up having that V squared then equals Ke raised to the power of 2 over m. So our V will then be the square root of Ke raised to the power of 2 over what? M. Don't worry, we are actually dealing with the positive value of the velocity, so we won't That's why I'm not putting the plus or minus. Okay, so with this n to this n, so let us now find the value of v. Then our k is 200, so our v here equals now 200 times our extension here is 0.05 all to the power of 2, then all over our m is 0.02. Okay, so let's calculate. So the numerator here first is 200 times 0.05 raised to the power of 2. So it will give us 0.5. So here we have that v equals to the square root of 0.5 then all over 0.02. Now this will give us the square root 0.5 now divided by 0.02. So this will give us what? 25. And the square root of 25 is what? 5. So here we have 5 meter per second. Alright, this is the solution to the question. And if you love what I've just done, please don't fail to like, to share with other learners. And don't forget to subscribe to my channel. Thank you and remain blessed. Bye bye.